Going to Mars has been a fixture in our cultural consciousness for a very long time. It feels like the inevitable next step for humanity. But almost no one talks about sending humans to our other neighbor, Venus. We have blockbuster movies, international space mandates, and private companies pouring billions of dollars into reaching the red dirt. Mars has the best public relations team in the solar system. But look at the physics of the two planets, and a strange contradiction appears. Venus is actually a physically and logistically easier target for human colonization. We are so focused on the dream of surviving a frozen desert that we are ignoring the most logical stepping stone right next door. Let's run the numbers. Depending on the specific launch window, a round trip from Earth to Venus is 30 to 50% shorter than a trip to Mars. This animated map shows the transit paths. Shorter transit times mean astronauts spend less time in zero gravity and take on less exposure to deep space radiation. A shorter trip requires significantly less food, water, and fuel on board. This chart compares available solar energy. Because Venus is closer to the Sun, a colony there would have access to roughly 4 times the solar power available on the Martian surface. Moving humans across the solar system is essentially a math problem of resource efficiency and payload weight. On a purely logistical baseline, Venus wins the math. The hardest constraint of long-term spaceflight isn't distance or fuel, it's gravity. Mars pulls at less than 40% of Earth's gravity. Venus sits at nearly 90%, a gravitational pull almost identical to what you are experiencing sitting in your chair right now. We have decades of data on what happens to human bodies without adequate gravity. In Earth orbit, astronauts lose bone mass at 10 times the rate of a patient with advanced osteoporosis. Muscles atrophy and cardiovascular systems weaken. We can manufacture oxygen and we can filter water, but we cannot manufacture planetary mass. Any permanent colony on Mars faces the guarantee of severe, multi-generational medical degradation. If Venus is closer, brighter, and biologically safer, why is it ignored? The answer comes down to a psychological bias we can call surfacism. Since the days of seafaring explorers, humans have been obsessed with planting flags in solid dirt. We assume that if you can't build a base on the ground, a place doesn't count. And trying to stand on the ground of Venus is a terrible idea. A runaway greenhouse effect has driven the surface temperature to over 450 degrees Celsius, hot enough to melt lead. Even worse is the barometric pressure. The weight of that thick atmosphere crushes the surface at over 90 Earth atmospheres. Walking there would be like walking a full kilometer underwater. We learned this the hard way. When the Soviet Union sent probes to Venus, the early models simply imploded in midair. It took heavy, spherical armor just to survive on the dirt for a couple of hours before being destroyed. Because the lowest elevation of Venus is a toxic, crushing oven, we rode off the planet. But we don't have to build on the dirt. If you look exactly 50 kilometers straight up into the Venusian sky, the environment changes completely. At that altitude, the temperature drops to around 70 degrees Celsius. That is still hot, but well within the range our standard firefighting gear can withstand. More importantly, the pressure drops to almost exactly 1 Earth atmosphere. This means human beings wouldn't need heavy, pressurized spacesuits to step outside a habitat. You would only need an oxygen mask and a protective, heat-resistant suit. The most hospitable, Earth-like environment in the entire solar system isn't a planetary surface at all. It is a layer of sky. Venus's atmosphere is dominated by heavy carbon dioxide. Because CO2 is so dense, our standard nitrogen and oxygen mixture is buoyant by comparison. On Venus, breathable Earth air acts like helium. A habitat filled with our air would naturally float. NASA has actually drawn up blueprints for this exact scenario. They call it the High Altitude Venus Operational Concept, or HAVOC. Compare the options. On Mars, colonists would spend their lives huddled deep in underground bunkers to escape constant radiation. On Venus, by contrast, colonists could spend their lives in massive, sun-lit floating cities, riding safely above the clouds. To expand beyond Earth, we don't have to conquer a freezing, low-gravity desert. We just have to let go of our need for